Alright, what's up my mathletes? That's right, Mr. Muscarella coming at you, and in this video I'm going to show you how to use Desmos to check your solutions to solving trig equations. So let's take a look at one of the problems that we've done previously, shall we? So here we go, we've got, we're using identities to solve these, so Pythagorean identities. So if you look at example 1, we've got negative sine squared theta equals sine theta minus cosine squared theta. And when we did all our work on this, we came up with this three solutions of 30 degrees, 150 degrees, and 270 degrees, or those equivalent values in radians are pi over 6, 5 pi over 6, and 3 pi over 2. Now, one of the things we want to pay attention to is that when we're asked to solve this, it's between 0 and 360, or 0 and 2 pi. So that means no negative values, no negative values. But let's go ahead and take a look at Desmos, and I'll show you guys how to go ahead and do this using the Desmos. So what we're going to do is we're going to take this left side of the equation, negative sine squared x, and we're going to put that in one line. And then the other side of the equation, sine x minus cosine squared x, that is going to go in the other line. So you're going to have two different lines, one for the left side of the equation and the right side of the equation. Now when you put those in, you'll get these two curves here. One of them's in red, one of them's in green. Now, to get the squared, you can go ahead and do that right here on the keypad. You have an a squared, so if you want to type something squared, you just hit that button right there, and that'll make it squared. And you get squared all day long. If you wanted to do different exponent besides that, you just do this next key over here. So that's one option. The other option is to hit the caret button on your computer, and then the 2 right after that. Now I'll pop it up there. Now instead of theta, we're going to use the variable x, because that's what's going to be easiest here right now for Desmos. So what we're going to do when we have this also, I want you to take a look over here on the right-hand side. Underneath the world, a little question mark and a little sharing button. You'll see this wrench, and that's your settings. Now, if you look at the print, so here's smaller print, here's larger print, but down here, what I want you to pay attention to is what's grayed out right here. It says radians. So that means the answers that it'll give us will be in radians. If we wanted our answer in degree, watch how that changes the graphs. So that's going to shift the graphs because now we're graphing in degrees and not radians. But for our purpose for this video, we're just going to graph it in radians. So we want to have that all set, and we're going to notice where things intersect. Now, where my two curves intersect right here, you'll notice when you click on it, you'll see all these gray dots pop up. And that's where the curves are the true, where line 1 and line 2 are the same, or in the case of our equation, where the left side is equal to the right side. So there's other values you'll see, other gray dots on here. If it's on the top of a curve, that means it's a maximum, and we don't want maximums. And if it's on the bottom of a curve, well, that would be a minimum, and we don't want minimums. And notice the minimum values, the y values are the same on all my minimum values, just as the the y values are all the same on my maximums. So there's all of those have a value of 1 for the maximums and negative 1.25 for the minimums. But we're not here to talk about maxes and mins. We're here to talk about where the curves are equal. So that's another spot. And another piece on here, when you click on a curve, you'll see these other gray dots that are on the x-axis. So that, notice the y-coordinate is 0. So anywhere you see that is where the x-intercept would be located. And the y-coordinate will always be 0, because that's what an x-intercept is. It's where a graph, a function, crosses the x-axis. But what we're interested in is where these two functions are equal, where they're equivalent. So we would look at the gray dot, that is where they intersect. And one you see is at negative 7 pi over 6. You'll see another one over here at positive pi over 6. You'll see a third one over here at 5 pi over 6. And you'll see another one over here at 13 pi over 6. So we can see, oh, and there's another one over here, yeah, at negative 11 pi over 6. So right off the bat, these two that are on the left, we're going to eliminate because they're less than 0. Because remember, we have a domain restriction. So we don't want to worry about those guys. But then these ones that are on the right, so we have pi over 6 and 5 pi over 6. And this guy right here, all right, pi over 6 and then 5 pi over 6. So if we go back to our problem from before, we definitely see the pi over 6 and the 5 pi over 6. But wait, where's 3 pi over 2, you ask? So when we have 3 pi over 2, oh, that's this guy right over here. So see, we missed a spot. And that's easy to do because you've got all these gray dots everywhere. So just look to see where they intersect. And of course, this gives us our answers in radians. So you'd have to know what the equivalent pieces are, what the equivalent measurements are in degrees. So anyway, that's it. That's how you determine where the values are the same for two trig equations. Put one in on the left, the other one in on the right, and see where the graphs intersect. All right, that's it for this video, man. Thank you guys for watching. I appreciate it. Get out there and make it a great day. There's no other reason not to. I'll catch you later. Peace.